Hello, everyone, and welcome to today's webinar. We will start in just a few moments from now. This webinar will be given by Ken Merritt. So, and trust me, he has a lot to tell us about the whole wizard.
We're going to cover quite a few things.
Yes. So just give us another 2-3 minutes as people are still joining. So we'll give them a chance to tune into us. And we will be starting very, very shortly. For those of you who are joining us now, we are still waiting just for a moment or two until a few more people join. They are trying to join, and they should be in a moment. And then we will definitely start the webinar, and this will definitely be a very interesting one. As I know Ken for many years, there is nothing ever boring about his webinars.
Don't set that bar too high.
Okay.
I appreciate it. This should be a fun one. We'll get into a little bit of how to use the whole wizard and kind of what makes it special.
Okay. Okay, Ken, I think we can get started. Hello, everyone. I'm Sydney, and this is a webinar on hole wizard and hole drilling, which will be given by Ken Merritt. Ken Merritt has been working on the hole wizard for many, many years, practically from when hole wizard has started, and he is full of knowledge of not probably one of the most knowledgeable people when it comes to Hope Wizard. This meeting is being recorded, so it will be available later on for everybody to watch. Also, there's the question pan that you can always ask questions, write down your questions during the webinar. If I can, while Ken is talking, I will answer, or I may feel also maybe it's better to wait for the question to be entered at the end of the webinar. So Ken, it's all yours. Go ahead and start. And
Okay.
We're all waiting and listening.
Let's go. All right, so what we're going to be talking about today is the hole wizard. And there's a couple of different things we want to cover. A lot of frequently asked questions over the years that we get. First off, what is the hole wizard? Well, let's kind of talk about that a little bit. The hole wizard is a machining process table within SolidCAM that allows the user to manage multiple toolpath operations as a process, okay? And that can be oriented towards any specific purpose. This allows us to preset parameters into the operations, and we can do that either hard coding a value in, or we have ways of automating parameters that can, pass values from the CAD system into the CAM operation dialog. So that's kind of a brief overview of what the hole wizard actually is. Now, when we start to talk about how can the hole wizard help me, that gets us into a different realm. The idea behind the hole wizard is it makes it possible for us to set up, particular user defined methods for drilling hole features and for machining circle milling and stuff like that for hole features. It actually provides a way for those methods to be adapted to the characteristics of the CAD feature that these processes are being executed on. And that's what brings an incredible speed in automation, as well as predictability, reliability, repeatability to the programming function of drilling and machining operations that are necessary to manufacture these hole features and parts, okay? And so as we begin to try to figure out how it works, there's a lot of different things that we need to talk about. And so we're going to start kind of with the foundation today and talk about how the SolidCAM Hole Wizard uses the same dialogue interface that you're used to using every day, but gives you the ability to program automation and do things the way you want to do things. You can assign parameters, equations, conditional logic statements, all kinds of things like that that help you calculate the proper values for the fields and the dialogues to meet the needs of the particular CAD feature that you're wanting to apply this to. And so as we go forward here, I want to talk just a little bit about some of the fables that are in the industry of what I like to call AutoMagic. All right. And there's a big difference between what we want to call automation and what some people think should happen magically. Okay. And what this system does is that the Hole Wizard makes it possible to do things that are not the normal. In a lot of people's imaginations, they think that we should be able to just simply scan the print or open up the solid model and then press the magical do it button and everything should be taken care of for us. Well, that's not really how automation works, okay? As we can see in this kind of image of a print here, there's a lot of different characteristics that matter when we're trying to machine something, and especially when we want to try to automate that process. And so that's a little bit of what we're going to talk about today and take you into some of the different ways to do these things. Some of the other things that people sometimes are not aware of that create a need for variance is the differences in machine types, okay? We could be talking about a simple 3-axis machine. We could be talking about a little bit more complex 4-axis rotary machine. We could be talking about 5-axis machines. Even different styles of 5-axis machines can have different requirements when you're machining a part. This can be approaches, this can be values that you want to leave in distances away from things. There's all kinds of different variables in here that really make a big difference. One of the biggest is the fact that each of these machines, depending on who made the machine, what controller it has, and like this one here, what its kinematic capabilities may be, it may require different drilling cycles, okay? And so those cycles can vary from one machine to another. So having a single process to manage everything in your shop may not make sense, and we'll talk about that just a little bit. Varieties in materials can also cause issues, okay? Cutting aluminum, we may be cutting different grades of steels. These can range anywhere from, very mild steels all the way into the fully hardened mold steels, into stainless steels that are necessary for medical devices and things of that nature. So these things can have a big impact. The type of material it is can have a big impact on feeds and speeds and other characteristics of the operation. We may be working with, high temp alloys like Inconel that are used in aerospace. This could mean, along with the other things that you're seeing here, changes in step downs and step overs, okay? Now, a lot of these things, especially when we get into super alloys, they're very, very particular. in how we want to approach them relative to the machining process, okay? And so as you can kind of see here, an all-in-one process, though possible, might be very, very difficult to set up and maintain. So I want to talk about how automation works a little bit and kind of give us an idea of how we can do a better job of managing our automation so that it is more reliable, it is more predictable, and it is more understandable, okay? And so let's talk a little bit about structured logic, okay? A lot of people are a little bit afraid of structured logic. It's not really difficult. It's pretty simple to work with if you have that mindset. Now, this particular example is a very simple structured logic statement that talks about one variable and essentially three conditions that need to be set based on the condition of the variable. So as we look at this, this says, you know, if the temperature is greater than 100 degrees and the temperature is less than 200 degrees, then we're going to set the pump on, we're going to set the flow to 45 CFM, and we're going to turn the green light on to say that the system is running, okay? The else if statement gives us the ability to add multiple statements within the if statement. And in this case, the else if is, well, if the temperature is below 100, so it's the first option wasn't true. The second option is if it's less than 100 degrees, then we want to turn the pump off, set the flow to 20 CFM, and turn the green light off to let everybody know it's not running, okay? And then there's a third condition here, all other conditions, meaning we're just going to use the else, which in this case, if the two previous conditions aren't true, then that means that we're going to be above 200 degrees, and that's not good. So we need to turn the alarm light on, okay? So you can see this is a very simple approach to structured logic. And as we go down a little bit further and we start talking about the environment within which we're working, there's some really interesting stuff about structured logic. When you constrain the environment to a workable set of parameters, conditions, choices, and so forth, then structured logic is fairly easy to work with, and it can be not so complex, okay? When we get into far more open areas of using logic, more randomness, if you will, structured logic can become very, very complex. And so there's kind of a thing that we look at in the industry of the more we can constrain the environment within which we want the logic to work, the easier it is to build, maintain, and troubleshoot that logic, okay? So with that in mind, I want to talk just a little bit about something we call permutations, okay? This is a very simple internet calculator that I found that gives you an easy way to look at calculating the permutations for the objects, to how many number of objects to choose from, and how many choices you want to include in the logic. So this is very simple, 6 items, okay? And we want to choose the combinations of only 2 of them. Well, that results in 36 permutations. There are 36 different options for choosing 2 of 6, or choosing any 2 of 6 items. Now, here's what happens, and this is where it starts to get challenging. Let's just choose 3 items instead of 2. Well, now there's 216 permutations, okay? Wow, that jumped up pretty quick, okay? So it's not a linear growth in complexity. It's kind of an order of magnitude, if you will. Let's take it one more step. Let's go up to 4. We have 6 objects to choose from, and we want to check 4 combinations, any 4 combinations of those 6 items. Well, suddenly that jumps to 1,296 permutations. So you can see very easily here that if you want to use automation and you want to build your own automation, then it stands to reason the more constrained you can keep the environment within which you want to work, the easier it's going to be to build and figure out and troubleshoot that logic. Okay, and that's kind of the road I want to go down today and talk about, because the whole wizard is actually a lot easier than most people think. It looks a little daunting on first look, but it's really not. So when we start looking at types of parts, there's something to think about here. There could be a great variety of parts that we're working on, and we want to apply automation to them. And so a lot of people think, well, I could only apply automation in this certain family of parts. Well, when we talk about whole wizard, it makes it a lot easier because we're just talking about holes. Okay, and there's not that many types of holes. And so that environment within which we want to build our automation is not so fantastically huge. Okay, we're talking about holes. There's only so many types of holes that we put in parts in machining. Okay, now there are some things that impact that, like tolerances. Okay, we may need to do a different number of operations or a different order of operations in a process to facilitate a particular required tolerance. Let me give you an example real quick. If I'm looking at a commercial hole, I'm going to put a 1/2 inch hole through this plate, and it's not really super important, the precision with which it's put in there. It's an aluminum plate. Yeah, maybe I can just drill a hole. I don't need to do really anything. If it's okay if the drill walks a little bit, I've got plus or minus on the size of the hole, I've got plus or minus on the location of the hole, then my automation becomes super simple. Grab a drill and plug a hole in the plate. Okay, not a big deal. If I start looking at GD&T requirements and I start seeing things more precise, like for instance, the diameter of the hole is far more precise. Maybe the plus minus tolerance is extremely small, or maybe it's one-sided, it's plus plus or minus minus. Then I may need to do different order of events when I'm creating the process. Like I might, instead of just drilling the hole like we were talking about before, if it's got a locational tolerance, maybe I need to spot drill that to help keep the drill from walking. Maybe I need to undersize drill it so that I can come back in with a reamer and bring it up to a more precise size. Maybe I need to chamfer it at the end of it instead of doing it at the beginning of it. There's all kinds of different things to consider. If it's an extremely tight, precise hole, both locationally and in the topology of the hole, I might have to spot drill, undersize drill, circle mill for location, ream it for prep size, and then use a boring tool, boring head, to go in and bore it to an ultra precision type of a diameter. So there's, just in those few examples there's totally different processes that need to be built. And we need to think about that before we start building our process. Fit, form, and function, for instance, the geometric tolerance in GD&T. Maybe the circle mill is necessary to make sure that it's truly on that position versus allowing a drill type tool to walk a little bit. Okay, so things to think about there. What SolidCAM allows us to do is to build in our own processes to achieve these results. And we have control over those processes where we can automate the values that we want to automate, and we can also use other values that are what I call hard-coded values. We just put a value in. I'll kind of show you that in a few minutes here. So whole wizard, whole wizard works better when it is driven by specific requirements. Okay, and we can keep that in order by knowing, okay, what machine are we dealing with? In what materials are we working? All right. And we can build multiple processes. So we don't have to build everything into a singular process. We can if we want to, okay? The logic becomes more difficult. There's a lot more to write. There's a lot more to double check. There's a lot more to troubleshoot. but we can do it either way, okay? I like an idea of keeping my processes simple and orienting them towards a particular configuration. For instance, here, I want to use a commercial hole in aluminum. That can be a very simple process. You know, for the most part, if I'm not tightly toleranced and I'm only putting it into aluminum, I can pull the drill size that I want and go plug a hole in the plate. Not a big deal. You know, if I'm working with hard steel mold plates, I might need a few different procedures to go in there. You know, if the mold is on a cavity side, I might want to circle mill a flat position for the spot drill to hit before I do anything else. If it's on a flat plate, I might want to run the spot drill before I do anything else. Okay. So all of these considerations, material, what the part is, so forth, may be things that we want to think about that dictate how we set up this MPT file. MPT stands for Machine Process Table. And each of these has a folder that carries all the operations and everything that we build to create this process, okay? And so we want to start thinking about that. Now I want to talk a little bit about what is the default hole wizard and why is there only one in the installation, okay? Well, it's pretty simple. It's a sample. It gives you an idea of how you can do a lot of different things, okay? And so it gives us examples of structured logic that we can build and why we might want to build it a certain way. A lot of this is just some creative ideas so that you've got something to look at that you can go, oh, I see what they did here. Okay, I could do this differently if I wanted to do it my way, okay? It gives us examples of how to use the parameters, okay? There's several different parameters that we can use throughout the hole wizard. There's user-defined parameters, which we'll talk about. There are part parameters, like the clearance level, the upper level, the lower level, simple things like that that come directly from the part in the project. And then there's also this list of hole wizard parameters. Now these are cool because these parameters come across from the CAD feature. And we've also done some feature recognition in the hole wizard that we can populate these same parameters from an imported file so that we can use the same logic, the same process to work on a native SolidWorks or Inventor or Solid Edge part, or we can work on a part that's been imported into any of those CAD systems from some other CAD system. So this gives us a lot of flexibility in what we're doing, okay? Also gives us examples of how to build equations. Now this is going to show us a little bit about how to create an equation. Now this is in a counterbore process, and notice we've got 5 operations in here. We're going to talk just briefly about the spot drill operation, and we're going to talk about the spot drill feed and how we set that parameter. Now in this case, we just used a simple equation. You can see this, the spot drill spin times 2/1000ths of an inch. So it gives us a 2/1000ths per rev function. We can also use functions in our equations like square root, sine, cosine, tangent, you know, various different mathematical functionalities that might make our equations more sophisticated, okay? So it's very easy to use these things within it and get what we want the system to do for this particular instance of how we're using this parameter, okay? Now, how do we start a new hole wizard? Or do we have to do something that's already built? Well, it's actually pretty easy, okay? So if we think about this, if you're inside a project, right? And let's take a look here at the folder where we store. This is an example of a folder where I'm storing different machine process tables, okay, including the default one, the folders that go with them. This is just kind of a simple example here. But I want to look at that. We're going to go ahead and start a new process and see how it works. Now, if we're inside a project, we can simply right-click on this node here on the tree, and we can create a new process. Give it a name. I'm going to type in KenM_test just for a simple one, and then add the machine that we want this to point to, because remember we talked about different machining cycles. Now when I pick one of these machines, the system is going to go evaluate all the post processors that are in my folder, and it's going to grab the group that have the same cycle types with the same options in the cycles, and any of those are eligible to use this process. Okay, so that was pretty easy. Now I can identify the name of the first process I'm going to do for tapped holes. Okay, I'm not going to go all the way through this. I'm just going to show you how to start this. When I save this, okay, let's go ahead and bring that folder back down again. And you can see that now I have a KenM test machine process table and its associated folder. So now we could start adding or editing or working with the process that we began to define. So let's start out simple. One of the first things I really like to do is identify my geometry. This is a user-defined parameter. Notice when I give it a name, I'm going to call this hole locations. It's pretty simple. And when I add this, you'll see that it goes into the unused parameters list. Now this is an area where we can pre-build a series of parameters that we know we're going to want to use, but we haven't chosen to use them yet. So let's open a drill operation. First thing I want to do is name the operation. So in this case, we're going to start with the spot drill. Okay. For tapped holes, I'm going to spot drill, and tap. For the geometry, I'm going to go ahead and grab that parameter that I just created. And that makes it pretty simple. Now I'll go in and select a tool. And we're just going to grab a default spot drill for right now. And we'll go ahead and save that. And I want you to see what that did in this process. Now it created a spot drill operation in the tree and an associated tool that goes with that operation. Okay. And so that's how easy it is to start from scratch and start building your own process. Now we can start automating. Okay. When we look at this tool selection, notice it came in with all the default values. Now remember, I said we can leave hard-coded values or we can turn these into parameters. I'm going to create a spot drill diameter parameter here. Now you notice I use underscores instead of spaces. That keeps everything clean. And when I save that, notice now we have that parameter, and all we need to do is set an expression for it so that when we apply this to a particular hole feature coming from the CAD system, it can automatically capture the value that we need from that feature. Okay, so I'm going to grab a thread diameter from the Hole Wizard processes, and I'm going to check in this condition to see if this is less than or equal to 0.2. If it is, then I want my diameter of my chamfer or my spot drill to be 0.250, a little bit bigger. Now I can put that else if statement in, and I can say, let's check that parameter again. So let's check the thread diameter. Hey, if it's greater than 0.2, right? And there's operators in here we can use, and I want to check it again if it is less than a larger value. Like for instance, in this case, I'm going to say it's less than or equal to 0.7 inches. Then I would want to use a 3/4 inch spot drill so that my spot drill is a little bit bigger than the hole that I'm trying to create. Now, if that's not it, hey, let's just go ahead and go to a 1 inch. Now, this is obviously very simple. You may want to do a little bit more granular depending on what you're trying to do. But this is how easy it is in SolidCAM's Hole Wizard to begin creating automation that can really catapult your productivity and give you the ability to very, very quickly plug and play a whole process operation and make it work. Let's go a little bit further and let's start doing some feeds and speed stuff. So I can create a parameter for spot drill spin. I can create another one for spot drill feed. Okay. I can also intermix parameters with hard values. This particular machine, I know I can move between the holes at 500 inches a minute anytime I want to do that. And so I don't really need to calculate anything automatic on that. I'll just plug in 500 and let's go. So very quickly, I've created that. Now, how do I calculate my spot drill spin for different size tools? Well, I can do a real easy equation. Let's say I want to use 250 surface feet per minute. So I can type in 250 divided by the spot drill diameter. So now we make it based on the spot drill diameter. I can make that a parenthetic equation, so I know it's going to calculate that first, right? And then I can say I want that value divided by 0.262. That gives me a quick, easy way of changing surface footage into RPM. Very fast, and it can vary based on the size of the tool that we picked in the previous conditional statement, okay? Same thing here with my spot drill feed. I can make it based on the spin value that I just calculated, and I can make it 2/1000ths of an inch per revolution. So you can see the order in which you create your parameters may also be important. If I'm going to calculate off of a particular parameter, it has to exist before I can calculate off of it, right? So again, this kind of gives us an idea of how simple some of this stuff really is. There's a lot of details here, but it's really not tough to use. Now, one of the best ways that Sydney and I have determined we can use these very effectively is to copy and edit existing processes. We do this all the time, okay? So let's talk about that and let's see what that does, okay? Anytime you're working in the product, again, whether you're inside a project or whether you're outside a project, you can get to the whole wizard processes and determine what to do. If you're in a project, you can just right click here on the tree and hit open. And then you can choose whichever one you want to make a copy of, right? In this case, we've got the default assigned. Now I'm going to close this project and let's just go back to the SolidWorks interface. You can also go up to the tools menu, and from here, we can go to the SolidCAM options and we can pick the whole wizard processes. We can open whichever one we want to make a copy of. In this case, I'm going to grab the default one. Now I can start figuring out what to do with this. First, I'm going to go down here to this drop down arrow and I'm going to save as a new name. I can name it whatever I want to name it for whatever purpose it is that I'm wanting to change this one and build new functionality into it or alternate functionality into it. So we'll call this Ken M for steel on a Haas. Okay, pretty simple idea. We'll go ahead and accept that. And when we accept this, when we hit the save button, let's go ahead and grab that folder again and say, well, we got to save this first. I'm sorry. We're going to save it as that name. So it identified it there. And now when we look in here, lo and behold, that MPT has been created and the associative folder is created that carries all the operations and such. So if you're going to move these around, make sure you get both the MPT file and the folder. Now I can go into any of these processes, edit them, take a look at what has been done in here, and I can change it for whatever reason I need to. Do I need a different order of events because it's a more precise process? Or do I need change feeds and speeds because it's a different material? Or do I want to change tool selection maybe because it's a different material? I can easily go into any of these and begin editing any of those characteristics that are there, including tools, levels. These are using some part parameters, okay? My spot drill diameter down towards the bottom here, that's using a user-defined parameter that is calculated off of the chamfer diameter that is a part of the CAD process, okay, whether or not it exists. So in this, let's take a look at that. Here's the spot drill chamfer diameter, and look at the condition statement. This is very simple, okay? So you can have complex logic or simple logic. If the HW near countersink diameter, it's a hole wizard parameter, means if in the CAD system they put a chamfer on top of the hole, if it equals 0, or it is greater than 0, excuse me, then I want to go ahead and use that value straight from the CAD system. If it is not greater than 0, it means that the user didn't put a chamfer on top, but I still want one in my machining process, so I'm going to grab the thread diameter, and in my case, I want to add 20 thousandths to it. You might want to add 1 millimeter or some other value. It's really easy to do, okay? And so it's very, very simple to go through these and figure out what these are doing. Now, we also want to talk about those drilling cycles. Let's say you copy this process from one machine to another machine. You just simply need to go through each of these processes and make sure that the selected drilling cycle lines up with what that machine supports, okay? Now, I'll show you in just a moment here how to add a new machine. In this case, we're looking at a G81. Well, we might want to use a G82 for that on a different machine. One machine may have a G82, one may not, okay? Now, there are other things that we want to see in here, and you'll notice the blue lettering is coordinated with the operation that is selected. And we have parameters for both the tool and for the operation. So we've actually even done some color coding in here to make it much easier for you to be able to find the parameters that you want to make modifications to, okay? Now, this is the Add Machine button down here, and you'll notice when this one comes up that this is oriented to one of the default posts. But if I uncheck that, I can see every post in my library. And then I can go pick the one that I want it to be, and it will orient it to any of them that are similar, have the same cycles, and so forth. And so copying and editing an existing process is really not bad. It's not hard to do at all, okay? I know it seems a little overwhelming at first, but it's really not. And let's take a look at how we use the hole wizard. Now, we can use it from the command manager, but let's take a look at the kit first. We're going to look at the toolkit. Notice there's only two tools in here. One's an end mill, one's a chamfer tool, okay? We're going to go ahead and run from the command manager, from the hole wizard process. This opens a dialog for geometry selection. We can use different configurations of the model. We can set up filters. We can do what we need to do. Here's the list of where the hole is. So if we pick a hole, the system is going to find that hole, and it's going to find all of the instances of that hole within that CAD feature, okay? Or based on feature recognition, the similarity of that. And then it's going to calculate and run this through all the processes that we defined in the hole wizard table, and it's going to generate the 3 different operations: spot drill, drilling, and tapping. Okay.
Notice also, everyone, that it also recognizes the exact type of hole is also.
Absolutely. Absolutely. We are doing feature recognition that captures that data and that information. And so now we can go into simulation. Let's go ahead and move this dialog out of the way before we hit the play button here. And you can see it's going to run the spot drill, the drill, and the tap all to the proper depths, at the proper locations, at the proper diameters, as you have specified in your automation process, okay? Now you can see it created these different tools that we needed for doing this, okay? So again, the system is very intelligent. It very quickly takes care of redundant tasks that usually take us a little bit of extra time. So in a few seconds, it can do what would take us several minutes each time. Now let's take another look at it. Let's use it with drag and drop, okay? So I'm gonna make another setup in here. You can see we've got setup 2 on the tree. Let's take a look at that tool library again. There's those tools that we just created for setup 1. And I want you to notice there are 5 tools in there, okay? So now we're going to go to this command task area. We're going to scroll down. We're going to grab the drag and drop hole wizard and simply drop it to one of the holes. and the system's going to automatically take advantage of the whole wizard process and begin creating the machining requirements necessary for that particular hole configuration. And it's going to show those 3 again. Now, we're going to simulate that. You'll see how quickly and easily it did that. Setup 2 gets us into the proper alignment on this 3-axis machine. There's your spot drill, and tapping. Very quickly done. And let's go back and take a look at the toolkit again, because this is pretty cool. It knew that it could use the spot drill that already existed. So it didn't have to create a new spot drill, but it did create a new drill and tap. Okay. So if you have tools in the toolkit that you need for the operations you're doing, then the system's going to make use of those. Else, it's going to create a new tool for you. Okay. Now, we talked about working with tolerances. So let's talk about this just a little bit. We have a new feature recognition module that allows us to, at the target definition, do feature recognition on the holes, classify them into categories we call, based on its direction of the coordinate system, the shape that it is, and the group of identical holes within that shape. And then at that group level, we have access to not only the actual nominal hole size from the CAD feature, but we also have access to min-max tolerancing. Now, right now, this is manual. We are working on capturing this data from Dimension Expert and capturing it from the Step 242, what they call PMI data, the Product Manufacturing Information Data, okay? But you'll notice here that based on what I call an asymmetric tolerance, minus 10 thousandths to minus 5 thousandths, it captured a 7.5 thousandths delta and gave us the modified dimension of 0.2425 instead of 0.250. Okay. Now, we can take advantage of that and use it. We can use it in a condition. Okay. When we look at our hole wizard parameters, you'll notice that they are subdivided. Each of these have a plus symbol on them, and they're subdivided to the toleranced dimensions in here being available for selection also. So in our equation, or in our conditional statement that we use, if we are working with tolerancing, we can also use the modified diameter, or the modified dimension, if you will. Okay. Now, let's see how that works. Okay, so I'm going to run this again. The toolkit shows you the tools that we were using, right? Okay, and we're going to continue on and create this next hole process. I'm going to use this for this O-ring hole, not the groove, but the hole that the groove is around. I'm going to simply drag this over, put it on that face. Now, it's going to, because I've got multiple operations in here for a simple hole, I want to grab the one with tolerances. And it's going to use that one to compute differently than it would the simple or the dowel. Okay. And in this case, we're going to notice, if we go back and we look at the toolkit, based on that tolerancing usage, it created a tool that was 242.5 instead of the 250, which is the nominal size of that hole. So these tolerances can be extremely powerful and give us the ability to make the automation more specific to what we're trying to accomplish. Now, again, the tolerancing functionalities are manual at the moment, but we are working on that and driving that towards full and complete automation. And that kind of concludes what we wanted to talk about today. Sydney, did we have any questions as we were going through this?
Yes, we had some questions over here. Some of them, yeah, actually talked about at the very end. But we'll ask the questions anybody so that everyone can hear what we were talking about. The first one is, can we find reamed holes done with SolidWorks Hole Wizard? And I think you just answered that, but you can.
Well,
Um,
yeah, we can. I think the question is more oriented around
right.
whether or not the system can determine a reamed hole from a different hole. Now, you did see I had a function in there for a dowel hole, which
Mm-hmm.
I might be reaming or I might be boring, depending on what I'm doing with it. One of the things we can do is we can color coordinate those. Okay, so currently there is not a way for the system to, here's where that AutoMagic thing comes in, magically determine whether it's a simple drilled hole or whether it's a reamed hole. Okay, that data may not be in the CAD feature itself. Now, as we go forward and we're beginning to apply the Dimension Expert data to the tolerancing so that we can see all of that, we are working on front-end logic that will allow us to see that data and determine which process we should use based on that tolerancing information instead of me having to manually do it like I just did. Okay, so that's in the process. It can be done manually right now with color coding in the future. Hopefully not too distant future, we should be able to do that fully automatically.
Okay, and one I think I've heard it several times you from different people, and I know you've answered it to different people privately on this. Uh, Here we go. Is the process? No, hold on a second. What tool search variables do you have checked?
Oh, okay. In this case right now, I've got kind of the minimum, basically the diameter, the tool type, the thread, pitch, things like that. Just a minimal number so that it's not looking too distinctly. Now, what we are also in the process of right now, it's in development. We're working on it. We're going through and diagnosing some of the early quirkiness of it, but we have the ability to assign tolerancing to the tool selection. And so each of the features of the topology dimension of the tool will have a tolerance allowance on them. And we can set that however we want to set it so that it could capture tools that are near the exact dimensions that the automation discovers, but not have to be limited to being precisely exact to them. So for instance, tool length, in a certain particular operation, I might not care if it's a 3-inch long tool or a 3.5-inch long tool. So on the tool length, when selecting it, based on the condition of that particular feature, it may calculate a tool that is, 2.938 in length. Okay, well, the odds of having one of those in your toolkit are going to be pretty odd, right? But if I'm looking for a 3-inch tool plus or minus a 1/2 inch, then anything that falls within that range, it could go ahead and use instead of creating a new tool. So again, that's technology that is coming in the very near future. We're working on it right now, right at current functionality. Just limit the criteria that it's looking for, and it should find your tools for you.
Okay, there's another question here. Is there a plan to group holes on different Z levels? Let me just say something about that, and then you can continue.
Mhm.
Right now, when you pick up, if you pick it as a particular hole, as Ken had showed you, it'll only take the holes that are on the exact same build. In other words, the exact same Z level, the exact same depth, and the exact same diameter, and the exact same type. Uh, if they are in a different group, it automatically groups it to that as it is in those levels. If you use drag to the surface, it'll group each one according to its particular Z levels itself. Ken, do you want to go any further on that one?
No, I think you did great.
Oh, okay.
Perfect,
Wow.
perfect explanation.
Okay. That is it. I don't see any more. Hold on. Here we go.
Ah,
Uh,
we got a late guy.
uh,
Somebody popped in right before the whistle.
if you have a standard tool library, can you assign the tool library and only use those tools?
Yes, should be able to.
Okay. Okay.
Um, unless we missed something, but I don't think we did. I've been
Uh,
doing that for years.
yeah, exactly.
Mhm.
Is there any plans to somehow tie the feeds and speeds to iMachining material database?
We are working on a lot of different thought processes on that. The iMachining database is not necessarily the perfect animal for drilling feeds and speeds, but it could be a point of origin, if you will, where if you've got a iMachining database assigned to it, that we also have a coexistent holes database for that, and you could assign uh, that type of functionality. We're trying to figure out how to do that properly to keep it as minimally confusing as possible. Okay, but feeds and speeds are one of those things that are kind of tough to nail down. Everybody's got their own opinions on what's the proper feed and speed for doing things. So we'll be looking at that in 24. That'll be something that we're trying to get into the system right now. Set your feeds and speeds. What I do is the different materials. I just set up a different process for that material and just change the feeds and speeds in that, and then I select it manually right now. With the front end logic, one of the things we could do quickly is check what the iMachining material data is, and then base the selection of the process on that, but you would still need independent processes.
Okay. There's another question here. Will this process creation be offered for other job types? I would imagine you're talking about such as pocket operations, for example. Um, right now, by the way, besides the whole wizard, we do have regular machining process which can be used. But I'm not going to go too deep into that. But Ken, maybe you can offer a little more insight on what he's looking
Sure,
for.
sure. Remember what I was talking about at the beginning of this presentation is the kind of the complexities of doing global automation. What we are doing right now is utilizing all of this time that we're spending with the whole wizard to learn how to optimize some of these processes and make them more efficient, uh, less likely to have troubleshooting issues, and more reliable. And so as we go forward and we start to expand, once we get the whole wizard stuff perfected and the feature recognition characteristics within the whole wizards perfected, we will take that into other areas of the software and begin to look at that. Now, as Sydney so well pointed out, we do have machining process templates right now, or machining process tables that you can do this, but they don't have as many variables in them. But you can make machining processes that you can kind of hard code the way you want to run them, and then just grab them and apply them, and they're very quick to use. Same kind of an idea as the templates, if you will.
Exactly. I'll just add one more point onto that. Nothing to do with the automatic recognition, but what we do have already today, and Ken had just mentioned the word templates, is one of the, and this is not to do with this webinar, but we will be talking more about this and also in the future, is that we do have drag and drop templates. These are actually operations that the operator or the programmer actually creates on his as own. Just takes an operation and saves it, and it can use that template as you created it, and you know exactly what's in there. You just use it and apply it to any pocket you want. You can make a whole library of different templates and use them exactly what you want, and you know exactly what's going on there. And it's probably one of the quickest way to actually get an exact operation the way you want it.
And we did a whole presentation on that several weeks ago that's recorded and on our website.
But we're okay. Let's continue. Let's see if we have anything. Will the process? Okay. Okay. There's. I'll take one more question for now. We have. Is there any plan to work with PMI data? What is the status about this?
Yeah, we are working on that right now in development, and we're looking at there's different systems that put it out differently, and so we've got to kind of analyze what we can get and how we can use it, but that is coming in the near future, hopefully very near future.
Okay, Ken, I think that is it. Again, thanks so much for putting all the time and effort into giving over this webinar. Again, I would like to remind everybody that this webinar has been recorded and will be later available later on our website. You can always feel free at any time to drop an email to Ken if you have any more questions on this, and I am sure that he is more than willing to answer them. There I go,
You
Ken. I
betcha.
put you on the spot again.
There you
Okay.
go. That's okay. That's no, absolutely. If you have any questions, please don't hesitate to connect with me, and I'll try to give you the best answer possible. We thank you, everybody. Appreciate you being here today, and go do some programming. Have fun.
All right. Take care, and everyone have a great rest of the week, and have a great weekend as well. Bye bye.
Bye.